Please note, the diagram in Sheet User is not generated by the application. It has to be handled by the user, and a basic knowledge of how to generate Excel diagrams is therefore required. When specifying the normal stress SL and shear stress SLM along an arbitrarily oriented plane in sheet stress field, the distances normal and shear stress along that plane are copied to columns A, B, and C respectively in Excel Sheet User. The stresses are scaled to the component Py of the initial stress. For every new line specified in sheet stress field, the values in sheet user are updated. In this diagram, the normal stress SL and the shear stress SLM are plotted as curves. The safety factor SF regarding shear failure along the plane can be determined with the strength parameters cohesion C and friction angle phi of the rock. The values C and phi can be specified, for instance, for a plane of weakness. Let's have a brief look at the shear failure criterion. In this example, Coulomb's failure criterion is used. Coulomb specified the shear resistance SR as a function of the cohesion C, the friction angle phi, and the normal stress SL. The failure line according to Coulomb is shown in this diagram. Along the plane in sheet stress field, any stress state SL, SLM above Coulomb's failure line means exceeding the shear resistance SR. Please note, abscissa and ordinate of the diagram used for Coulomb's failure line are the same as used for Moore's circle. The safety factor SF regarding shear failure can be expressed as SF equal to shear resistance SR divided by the shear stress SLM, in which a safety factor SF less or equal to 1 means shear failure. The values for the cohesion C and the friction angle phi have to be entered in this input form. Py is provided by the program in cell H4. The formula for the safety factor SF in cell D2 contains a tension cutoff condition at SL less or equal to 0. This tension cutoff implies that the shear resistance SR is 0 as soon as the normal stress SL is less or equal to 0 or in tension, respectively. Please note, in the formula, the term when is German for the English if statement and is used for considering the tension cutoff condition. In cell D2, the user can specify his own failure criterion. I copy now the cell containing the formula for the safety factor down along the plane. In the diagram, the magenta line shows the distribution of the safety factor along the plane in sheet stress field. The safety factor's ordinate is given on the right of the diagram. Due to the tension cutoff and the plane section within the excavation, the safety factor's distribution contains discontinuities. Changing the cohesion values, let's say 5, 10, and 15 megapascal, reveal the influence of this parameter on the safety factor. The dashed magenta line at a safety factor equal to 1 marks a failure limit. Points at or below this line indicate shear failure. In this diagram, safety factor curves have been generated as functions of the factor of lateral side pressure K. The rock strength parameters cohesion C and friction angle phi are constant. For the plane's orientation in sheet stress field, the results reveal the considerable influence of the factor of lateral side pressure on the safety factor regarding shear failure. Please note any modifications, interpretations, and conclusions gained from the result in this sheet are in the sole responsibility of the user.